Hello and welcome to SigmaXL video tutorials. In this video, I'll be demonstrating Welch's ANOVA, which is a test for multiple comparison of means. It is a modified one-way ANOVA that is robust to the assumption of equal variances. Welch's ANOVA is an extension of the two-sample t-test for means, assuming unequal variance. Non-parametric methods can also be used, but they are not as powerful as Welch's ANOVA. To demonstrate Welch's ANOVA, we'll be using a sample set found within SigmaXL called Customer Data. To open Customer Data, click SigmaXL, Help, Sample Data, and then find the file customerdata.xlsx. To run Welch's ANOVA, click SigmaXL, Statistical Tools, Welch's ANOVA. This is also available in equal variance tests. Ensure that stacked column format is checked. Select Responsiveness to Calls. Click Numeric Data Variable Y. Select Customer Type. Click Group Category X. Check Display Test Assumptions Report and click OK. The p-value for Welch's ANOVA is 0.0135. Therefore, we reject the null hypothesis and conclude that the group means for responsiveness to calls are not equal. From the pairwise mean difference, we conclude that the mean responsiveness to calls is significantly different between customer type 1 and type 2. Note that the default probabilities are Welch's pairwise. An alternative probability option is Games-Howell, which I cover later in this video. A graphical view of the responsive to calls mean and 95% confidence intervals are given to complement the means matrix. Note that the standard deviations are unpooled, resulting in different confidence interval widths for each group. The fact that the CIs for customer type 1 do not overlap those of type 2 visually shows that there is a significant difference in mean responsive to calls. The overlap of CIs for type 2 and 3 shows that the mean scores for 2 and 3 are not significantly different. Welch's ANOVA Assumptions Report is a color-coded text report, whereas green is okay, yellow for warning, and red is a serious violation. Each sample is tested for normality using the Anderson-Darling test. If not normal, the minimum sample size for robustness of the ANOVA test is determined using Monte Carlo regression equations. If the sample size is inadequate, a warning is given and the appropriate non-parametric test is recommended. Kruskal-Wallis if there are no extreme outliers, or Moods median if there are extreme outliers. Each sample is tested for outliers defined as potential, likely, or extreme. If outliers are present, a warning is given with a recommendation to review the data with a box plot and normal probability plot. Each sample is tested for randomness using the exact non-parametric runs test. If the sample data is not random, a warning is given and recommendation to review the data with a run chart. A test for equal variances is also applied. If all sample data are normal, Bartlett's test is utilized. Otherwise, Levine's test is used. Since we're using Welch's ANOVA, it is confirmed as appropriate. Press F3 or click Recall SigmaXL dialog to recall the last dialog. Uncheck Display Assumptions Report. Click the Options button, select Games-Howell. Check Display Residual Charts as shown. Clicking OK will provide us with the pairwise means difference and Games-Howell probability results. The significant Games-Howell probability values have not changed as compared to Welch pairwise, but note that they are larger to compensate for the family-wise error rate. Click the Welch's Residuals Sheet tab to display the residual plots. Residuals are the unexplained variation from the ANOVA model, actual, predicted, or fitted values. Note that the residuals are not normally distributed. as expected from the assumptions report. But like the regular ANOVA, Welch's ANOVA is quite robust to the assumption of normality. Also, as expected from Levine's test for equal variances, the variability for type 2 is less than type 1, but Welch's ANOVA is robust to the assumption of equal variances, so we can trust that the p-values are valid. This concludes the Welch's ANOVA test for multiple comparison of means. For more videos, visit us at www.sigmaxl.com or join us at our YouTube page. Thank you for watching.